So I'd like to introduce you to the concept of a random variable. A random variable is basically just a mapping from some sample space to a real number. In order to demonstrate this to you, I'm going to start by drawing on a dartboard. Now I want you to imagine taking a whole bunch of shots at the dartboard. Now for any one of these shots you might be interested in some of its attributes. For example, let's look at this shot for a moment. You might be interested in its distance from the center, maybe you're interested in how many points it's worth, or perhaps you're interested in something else like its x-coordinate. All of these are numerical values that you can assign to each of these points. Now in order to demonstrate this, let's actually add on an axis. And let's go ahead and mark the distances as well. Now I'd like you to focus on one particular location where I could have shot. I'm going to go ahead and label this location L. And as you can see, L is equal to the coordinate minus 40, 30. Now we can go ahead and label the values on this dartboard as well. Now you can think of L as a member of the sample space of all the possible locations where you could have actually landed a dart. Now, for L, we can actually see that it's worth 1 point. Using Pythagoras' theorem, it's actually 50 centimeters from the origin, and its x-coordinate is just negative 40. Now we can go ahead and mark up all of this information directly on 3 different number lines. Now we can go ahead and map this element L directly to these 3 number lines where they belong. Now as you can see, this value L has been mapped to these positions using some kind of function. We can go ahead and name the first function capital V. The second function can be called capital D, and the third can just be called capital X. Now these 3 functions took an element from the sample space, and they went ahead and mapped them directly to a real number. These functions are called random variables. So we can see that we can get this value little v directly from L using the random variable. If we actually go ahead and sub things in, we can see that capital V of minus 40, 30 is just the number 1, as we expected. Using Pythagoras we can get the distance as well, which we can write like this. Now you may recognize the special triangle. If one of the sides is just 30 high, and the other side is 40 wide, then you know this side must be 50. Finally, this last random variable just takes the x-coordinate of our location L, which in this case you can see is just minus 40. Again, we can write this as I've shown. All 3 of these cases display 3 different kinds of random variables. In order to know that we have a random variable, we usually denote them with a capital letter, as I've done in all 3 of these cases. The name of the letter doesn't really matter at all. As long as it's a capital letter, you know that it's a random variable. If we like, we can go ahead and actually visualize x as a function machine. As you can see, the input to x is our element, L. We can then go ahead and feed it directly to the machine, and out the other side we just get the x-coordinate, which in this case is just minus 40. Now these 3 random variables can actually be categorized a little bit differently. The first random variable can't actually take the value of 1.5, because there is no 1.5 on the dartboard anywhere. So this value has gaps between it. Because we only have a finite number of values that we can take, we call this a discrete random variable. On the other hand, the distance isn't actually limited to any particular value. We can really have any value we want. We can always pull this element L as close or as far as we like. Therefore, we would say that the distance is a continuous random variable. You can also think of continuous random variables as being able to take any one of the infinite number of values on the number line. One of the very common uses of random variables is to actually construct sets that we'll use in our probability calculations, since after all, probabilities work on sets. For example, we know that this position L mapped directly to the value of 1. Now as you can imagine, there are actually very many places where L could have landed that could have given you 1. So you can imagine there's a set that contains all of the ways where you could have gotten 1, as I'll go ahead and draw right now. Now I'd like to tell you how we can actually go about constructing this set directly. If we think of this set like our event space, then we can think of our event space as the set of positions that map to the value of 1. We can actually write this mathematically as shown. Now don't be scared off by this notation. I'll go ahead and explain every part of it. We're saying that we've just formed this set of elements where L is inside our sample space. Given that, the value of L equals 1. Now we're going to do this so often that it makes sense to actually shorten it. So basically this is saying that our event space is formed by taking all of the positions where the output value is equal to 1. If we want to be a little bit more general and we want to talk about a random value, little v, then we can just go ahead and replace the 1s for our little v. You'll also very frequently see people leave off these curly braces. That's just a notational trick just to save a little bit of time. It's actually possible to form your event space out of any condition we like. So it's also possible when you're dealing with continuous variables to have ranges. So you might be interested in forming your event space out of all the positions that give you a value somewhere between 30 and 40 as the x-coordinate. I can go ahead and mark this directly as a set as well. As you can see, any position inside this region will always have an x-coordinate somewhere between 30 and 40. We can go ahead and write this set directly as well. Again, we're just saying that L is an element of S where the x value is somewhere between 30 and 40. We can also go ahead and shorten this too. So I hope you understand that random variables just give you a useful way to take any element of your set and write it in terms of a number. You can also use conditions on these numbers, like the condition where we wanted a number between 30 and 40, to form new sets that we can use in our probability calculations. So in summary, a random variable is really just a function that takes any element of your sample space and gives you back a real number.